All right, welcome to the final review. These are just slides that are going to be review problems and topics for the final. And this is the last hike I will tell you guys about this semester. How sad. It's called the Goat Trail. You can see down below, down here, that this is a river. It's the Buffalo River. Probably many of you, some of you have floated the river before. And over here, I don't know if you can see, there's a person right there, is the trail, okay? So this trail kind of follows the ledge. It goes back in there, and essentially you're along this ledge as you hike, and it's just really pretty overlook. It's a little bit of a hike to get to the actual goat trail. Here's another picture from the goat trail down on the river. So again, if you don't like ledges or hiking close to ledges, this is probably not recommended for you, but really great trail. The only other thing I have to say is why they call it the goat trail. They believe kids used to walk this trail to go to school with their little goats or lambs or whatever. I can't even fathom. I mean, where would you have to live to walk to school this way? I don't know. But that's just kind of like the story that's passed down. At least that's what I've heard. So I'm passing it on to you. All right, let's get into the actual review part. So I don't exactly know what this is going to look like. It looks a little different every year. Here's what I can tell you for sure. I'm going to talk through each chapter, honestly, briefly, okay? I'm going to point out topics from each chapter that I think were the most important topics. And then I want you to take those topics and go back to your notes from the semester. Hopefully you took good notes. Go back to your own chapter slides, okay? The lecture slides corresponding to that chapter. Go back to the textbook and study those things, okay? Also, you don't see any here, but what you will see, sometimes I'll work a problem. So like we'll work a problem on this second slide here for chapter 1, just a conversion problem. I'm going to frequently have problems like this in bold listed throughout the review. And these are problems from the book. I may take time to work 1 or 2 or 3 of them here and there. Most of them I'm not going to work on this particular talk. I will work in different Google Meet sessions, live sessions I'll host throughout this week and next week in preparation for the final. So I will point out these problems to you and I'll say, hey, this is a good problem to work for this topic in the textbook, but I won't necessarily take the time to work it here. I can, however, work it later. If anybody has a specific question on a particular chapter problem, I can work those in Google Meet sessions, individual or the group ones that I plan as well. So let's get on with it. Chapter 1, here were some of the big things from chapter 1. Classifying matter. Okay, you need to know terms like pure substance versus a mixture. Okay, a mixture is not a pure substance. What would be a pure substance? Well, a compound would be a pure substance in an element. These are pure substances. There's a whole chart, kind of like a flow chart, that helps you classify matter. We have different examples of a mixture. We have heterogeneous. And we have homogeneous mixtures, okay? Under homogeneous, we know that's where solutions are. We spent a whole chapter studying solutions. So you need to know these terms, know how to differentiate between them. Go review the lecture slides on those words as well. Okay, 4 signs of a chemical change. That was another, I think, important topic that we learned from chapter 1. Let's go ahead and list those. And I'm really going to zoom in so that I write kind of small because I don't have a lot of space on these slides. So number 1, you can probably think of these, write these down on your own paper. But if we got a temperature change, that was a sign of a chemical change. 2, if we formed gas bubbles, that was a sign of a chemical change. 3, If we formed a precipitate, formation of a precipitate. And additionally, the one I haven't written, color change. These are the 4 signs of a chemical change. Be able to look at different simple examples. Okay, if I told you burning wood, okay, you would need to be able to tell me, is that chemical or physical? All right, if I said cutting your hair, is that chemical or physical? Okay, bleaching your hair, is that chemical or physical? Be able to look at simple processes like this, water or a puddle evaporating, and tell me whether it is physical or chemical. All right. Additionally, you need to know prefixes. These are the 4 you need to know: kilo, centi, milli, micro. Okay. You need to know the relationship to what we call the base unit. Remember, we have 3 different base units for length. We have the meter, okay, for mass. We have the gram, and for volume, we have the liter. So meter, gram, and liter, these are our base units. And you need to know the relationship of kilo, centi, milli, and micro, how these prefixes change those units. Kilo makes a unit bigger by 1,000. Centi, milli, and micro, those prefixes make these units meter, gram, and liter smaller. Okay, a centimeter is smaller than a meter, so on and so forth. All right, temperature conversions. You have to do temperature conversions, and you will be given the equations for Fahrenheit to Celsius and Celsius to Fahrenheit. So what are we missing? You need to know how to do Kelvin to Celsius and vice versa. All right. You need to know that if you take a Celsius temperature and add 273.15, don't forget the decimals, that's going to give you the temperature in Kelvin. All right. So know those things. Density is another very important topic from chapter 1. Remember that density equals mass over volume. So I'm giving you a bunch of equations you might want to write down, because you will get a note card on the final. Equations you may want to put on your note card or memorize. So remember, the units for these is mass. Sorry, I'm not trying to write the word again. It's gram per milliliter. Okay, that's our unit of volume here, gram per milliliter. So we can convert between mass and volume with density. All right, we can use it as a conversion factor. So I would suggest notice I don't have specific heat on here. All right, specific heat is not on here. That's because it's not going to be on the final. What I would suggest, we did a whole lab, a dry lab, like week 2 of the semester, on problems with conversions and density. There was a lot of problems with specific heat, so don't rework those problems. But if you guys go back and print off that dry lab on like density and conversions, that would be a really good thing to practice working problems for the final. Okay. Real quick, we'll do some example conversions here. Carry out the following conversions. 14.4 micrometers. Remember, the abbreviation for micrometer is that U with the fun tail. So micrometer to millimeter. All right. So we need to know the relationship that there are 10 to the 6th micrometers in 1 meter. And we need to know that there are 1,000 millimeters in 1 meter. Okay, if you want to go directly from micrometers to millimeters, go for it. I'm going to go to meters first. So start with the number given, 14.4, and that is micrometers. Then I'm going to convert to meters using this relationship over here. So I'm going to cancel out micrometers, 10 to the 6 micrometers on bottom, 1 meter on top. Now I'm going to go to millimeters using this relationship over here. 1 meter, 1,000 millimeters. Okay, so what you should have is 0.0144 millimeters, and you obviously need to cancel out the units that you have on top and bottom, and this is your answer. Okay, so be able to do simple conversions like this. Kilograms to centigrams, so we need to know the relationship between kilograms and grams. 1 kilogram is 1,000 grams, and then 1 gram is 100 centigrams. Okay, so start with the number given, 1.35 kilograms. We're going to convert to grams using this first relationship over here. Kilograms need to cancel. 1 kg on bottom, 1,000 grams on top. And then convert to centigrams. So for every 1 gram, there's 100 centigrams. And I wrote grams on bottom so that grams cancel. And everything cancels but centigrams. So that's going to be times, oh goodness, that's a big number. 135. I think it should be that. Okay, or you could write 1.35 times 10 to the 5th. There you go. And oh, don't forget your units, centigrams. So simple conversions like this are part of chapter 1 that were really important